your documents could talk back with accurate answers. Hi everyone, my name is Bruce, and today I'm excited to show you my enhanced Retrieval-Augmented Generation system, now powered by Qdrant, a high-performance vector database perfect for scalable semantic search. This system allows users to upload documents such as PDF, Word, or CSV file and ask questions directly based on this content. Let me show you how it works behind the scene. So we're using Streamlit for the GUI processing, and by default we have the Qdrant on, but you can tap to see we have the vector store here. The system will be able to detect which type of vector store you selected and which type of vector store type it was being passed through. So we're just gonna go with the Qdrant. Now we need to upload the document that is gonna be used for all the data. So we're gonna upload this document here, and here this side is gonna show the process of whatever is going on. If the text is being extracted, it's gonna print there. So you see done extracting pages. It's trying to send information to our server, but now the Docker is not running, so it shouldn't be able to save the Qdrant. So let's see. So you see, it's gonna give us this error, Docker not running. So we're gonna go here. So I already did all this stuff by pulling the Docker file from Qdrant. Yeah, so, and the Qdrant is running on port 6333, and I'm mapping that to my local port of 7000. And then I'm down using my local storage as a mirror to the storage of the Qdrant. So whatever is going on in the Qdrant whilst the Docker is being running, all the vector stores is going to be saved on my machine. Even if I delete the container, it's still going to open. And I gave a name Qdrant hyphenated rag, so it will be able for me to just call that container. So we're just going to activate it now, so we can just So we're gonna start Docker start, and the container name, which is Qdrant. Right. So now we start it. You see here, it's starting. So now we'll just go back and try to upload the document again. So now it should be successful. Let's see. Let's try to refresh and see. Okay, let's upload the document. Let's see. Just want to show you what is going on in the server. Our server disconnected without sending information. So now you see it's doing whatever it's supposed to do. So it's contacting the Qdrant collection, and now embedding and everything is successful. So we can go ahead and just type our question to it, and then it's gonna give us the information we need from the text. We need from the documents. So I'm just gonna upload something here. By saying, okay, what is in this document? Then it's gonna go through the same thing, because the system, the GUI contains the part. Whenever it upload, it gives you the upload was successful, it doesn't just give you the upload is successful. It comes back with a part to your vector location, like the path to that vector store. So whenever you send a message again, the query goes with the location of your vector store that was being saved. And then it goes back to open that vector store and try to do the RAG on it. And I'm going to show you what is going on. So this is how it encrypts it. We first check if the collection name is not already created. If it's already created, meaning I'm the same person where I'm trying to do it. So it's going to just bring back return as the collection name, because with everything it's just like a reference to everything we're doing. So then it comes back to here, it does the RAG. So the system will be able to detect if it's a quadrant or we're using the FAISS vector store. So which one it is, it takes that one, and you can see the URL of the host is the local host, because I'm using a local machine like with Docker. And then it goes back to it, and then as a retriever, and this context is being passed into the prompt template together with the question that was being asked. And the AI model, the large language model, has access to this template, so we'll be able to format, the system will be able to format the context and the question altogether whilst passing it to the large language model. That will be able to go through all the context to know the information that we need from the document, because whenever we send the information, we send the query, it's going to do a similarity search on the retriever, and it's going to return the top with similarity search to us. And then it's going to be embedded in the, it's going to be using an F string to format it into a text file, a string that will be passed into the large language model, so you'll be able to go through and give us the information we need. This is a RAG system. This is what I develop and how I do it. And after doing some stuff on it, I came to a conclusion on the difference between the FAISS and the Qdrant. Qdrant is way ahead because of its eyes. I wrote some stuff here that I would like to show. So with the quadrants, right? Real-time updates, yes. You can insert as much as data as you want, as you processing. You can delete it too. So I can insert a button there that the person, if the person is done, the user is done, it can just click it and delete the collection name and every data from the system straight up. But the FAISS does not do that. I need to go there manually to do that. And when it comes to filtering, it's crazy. It's marvelous, because when it comes to the Qdrant filtering, you can filter based on the dictionary or like the metadata of the document. So let's say you're filtering and you want to like get information about the document, and you uploaded maybe a PDF file, a doc file, a CSV file, but you want that information specifically from a PDF file. You can use that filtering to do that. It's marvelous. The FAISS doesn't have that. And when it comes to scalability, right, it's high, because you can use their cloud to do the API call to the REST, or you can use the Docker that I'm using right now. So everybody on my system or everybody on my network will be able to access the Qdrant GUI only if you are on my Wi-Fi. And which is something that the FAISS doesn't have, because the FAISS is limited to memory. It runs in the memory. It's just like the Chroma DB. It runs basically in memory. So whenever like you turn off your machine, you turn it back on, every data is gone. Even if you don't turn it on, you try to clean your temporary files, everything is gone. And you can do the storage, like persistent storage when it comes to Qdrant, which one I did by mirroring, what do we call it? How do I put this? Like hosting your folder path and mapping it inside the Docker. That's what I did. So all my information, whatever I was doing, is being saved on my machine in the location I gave. Was I hosted, like I mounted like my file, my Windows location folder into the Docker container for data persistence. So all the stuff vector store I've done, I go here, I'll be able to see everything I did. And this is the latest one I did. You see, even if I turn off the Docker or I delete the Docker, it's still here because it's saved on my machine. That is how persistent it is. It's marvelous. And then this, you can force it to do, but in default, it's in memory. You can force it to save local, but default is in memory. And the Qdrant, like I said, has API calls, because if I show you the terminal, you'll be able to see that whenever it's done, like doing the similarity set, it makes an API call to my local host on some stuff, on an endpoint. You will be able to see that it has that. And then collection, like whenever you want to save something, all you gotta do is just give a collection name for the user, and then you just save your documents to there, and you use that collection name as a reference to their documents. That's it. When it comes to FAISS, it doesn't have that. You have to manually do that to save into a part. But if you do a main memory, it's gone. That's how it is. But when it comes to the Qdrant, you can give a collection name, and it's gonna be mapped to that. So whenever you call that document name, like the collection name, it's gonna go inside that container to pick up the context and try to do the similarity search on it. And then when it comes to production wise, because you can run it from container, runs on the server, Qdrant is perfect for that. And when it comes to FAISS, like I did, you have to do some keys and everything on it, just like I did. I did some codes on it to make it work on my server. So I'm just gonna show you the code and see. When it comes to the FAISS, the FAISS, you have to do all this stuff. It doesn't have like just from document, then you try to save it. Then you have to keep track of that stuff to load it back. So let's say if I change a part, or like my system gets like some glitches happen, I won't be able to access this. I have to go back and rectify that error before I'll be able to process. But when it comes to this, because it's being mapped on just a port, it's able to work fine. Yeah. And this is how I conclude everything. And thank you for watching, and thank you to Qdrant for showing me their project and doing more research on it to see that it works fine and everything is good for that. Thank you. Have a good one. And one last thing. And the GUI doesn't just have this. You have also the option to, let's say, I want to say the document was talking about ASW, and so okay, it has a natural language tokenizer stuff in it. So I can just say, what is in this document? Then I'll try to create a picture out of it. Take a picture out of it. Then we can pass in a picture even without saying anything. The system is built on top of a PY Tesseract and OCR to be able to pick up the text on it. So I can just drag here and try to upload it here. So you see what is the NTK in this file. It's gonna extract the text in the picture and pass it through the RAG system, and still we get an answer. So let's say you have a page where you can copy text or have a long text. You don't want to write everything. You can just take a picture of it and send it, and we'll be able to do an OCR on it and give you the information. Thank you, everybody. Thank you for watching, and shout out to Qdrant. Have a good one, everybody.